Assalamualaikum. Hi, welcome to the second part of Chapter 9, Probability of Combined Events. I am Nur Azlina binti Abdul Majid from Sekolah Menengah Sains Rajatun Azlan Shah Taiping. The second part is dependent events and independent events. Learning standard is differentiate between dependent and independent events. So I hope at the end of this class, everyone who watched this video will know how to differentiate between dependent events and independent events. Okay, let's say we have two events, event A and event B. What is the meaning of independent events? Independent event actually, let's say event A and event B are independent events if the occurrence of event A has no effect to the occurrence of event B. No effect to the occurrence of event B. And what is the meaning of dependent events? Event A and event B are dependent events if the occurrence of event A has effect to the occurrence of event B. Okay, let's try this question. Write a sample space for the combined events below. Box Q contains 3 cards labeled with SAM. 2 cards are chosen randomly from box Q, one by one without replacement. So here is our clue, without replacement. So it means that the card draw will not be written. Okay, let's say we have two events. Okay, event A and event B. So event A, take the card from the box for the first time, and event B, take the card from the box for the second time. Okay, event A. We have 3 possible outcomes here, SAM. So, and A is 3. Okay, and how about event B? 2 only. How come even possible outcomes for event B only 2? Okay, from the question, without replacement. Okay, without replacement means the card draw will not be written. That is why the possible outcome have only 2. So remember the word of without replacement. So the possible number of outcome and S and A multiply with NB, it is 3 times 2 and it is equal to 6. And then this is a dependent event because event A is affect the event B. Okay, so for the first event, the possible outcome are 3, and then for the second event, it is become 2. So event A is affect the occurrence of event B. Okay, Do you still remember how to get the possible outcomes? Here I will show you two methods. And what is the most important thing is I hope you can see how independent event and dependent event affect the number of sample space. Okay, here we have three possible outcomes S, A, and M. Okay, so the first method is what do I call as a tree diagram. Okay, so the first trial we will have three possible outcomes that S, A, and M. But for the second trial, we only have two possible outcomes because when S was taken on the first try, then no further S for the second trial. And look at A and M. So when A was taken on the first try, then no further A for the second try. Okay, and then same goes to M. When M was taken for the first try, so then no further M for the second try. So now we have 6 possible outcomes. So where is the possible outcome? Okay, so look at the path. Okay, look at the path. S, A. Okay, so S and A. So this is the possible outcome. And then here S and M. And here A and S. Then A and M. M and S. Last one M and A. So we have 6 possible outcomes. And now we can list down all the possible outcomes. So this is how we can get the possible outcomes by using the tree diagram. Okay, the other method is we can also use a table to find out all the possible outcome. So here is your table. Okay, so we write down the possible outcome S, A, M, and then here S, A, M. This is for the first event. This is for the second event. Okay, and as we know that it is without replacement, so means that the SS will not be happen. Okay, so SS, AA, and MN. Okay, I block already. Okay, so we just fill up the table S A S M S A S A M M N S and M N A. So why do we still got the same answer? Okay. Okay, now we go to the second question. Write a sample space for the combined events below. So look at the question. Box Q contains 3 cards labeled with SEM. Two cards are chosen at randomly from box Q one by one with a return. So here with a return. Before this, without replacement. And now with a return. Okay, still two events, event A and event B. Event A, take the card from the box for the first time, and then event B, take the card from the box for the second time. Okay, for A, the possible outcomes, SAM, so it is 3. And then for event B, it is still 2 because why it is 3 because the card is placed back, so the number of cards will still same 3 cards. So how many sample space are there? So NA multiply with NB, so 3 times 3, so we have 9 possible outcomes. Okay, so this is an independent events. Look at here, event A has no effect to event B. Okay, let me test with 3 diagrams. We have 3 possible outcomes, that is S, A, M, S, A, and M. When S was taken on the first try, possible outcomes are still S, A, M for the second outcome because this is independent events. So the possible outcomes still S, A, M, S, A, M, S, A, M, and then we can get the possible outcome, get the path S and S, S and A, S and M, A and S, A and A, A and M, M and S, M and A, N, M and M. So how many possible outcomes are there? It was 9. Okay, this is the table. So we just write down the possible outcome SAM, SAM. So we just fill up the table. So at the end, we still get the same answer is 9. Okay, we go to example 2. Identify whether the following combined events are dependent or independent event. Justify your answer. Okay, please give a reason why it is a dependent or independent event. Okay, obtain the tail twice when fair coin is tossed twice. So tail and coin, so what is the relationship between them? So what can I say? This is okay. The first try, H and T, and then red coin. And the second one, the second toast is H and T. Okay, so it is independent event because event A has no effect to event B. Okay, now we go to B. Obtain a tail in tossing fair coin and obtain the number 4 in rolling a fair dice. So this is a coin and this is a fair dice. So the possible outcome for tail 2 and the possible outcome for fair dice 6. So this is a this is an independent event because event A has no effects to event B. Okay, next, obtain two pens. Two pens of the same color when two pens are taken out one by one from a container that contain 3 red pens and 2 blue pens without replacement. So the without replacement means that it is a dependent events. Okay. So for dependent event, we take the first red pen. So uh, it was no red one pen for the second event. Okay. So this is the table. So this is the dependent event because event A has effect to the event B. Okay, that's all about dependent and independent events. So it's a quiz time now, and hopefully you are ready to answer all the questions. Okay, so uh, events for which the occurrence of one event does not affect the probability of the occurrence of the other. So which one, A or B? Now we go to the second question. Uh, uh, Events for which the occurrence of one event affects the probability of the occurrence to the other. A or B. And then the third one, Ali roll a number cube. Ali roll it again. So which one? Dependent or independent event? Sally flip a coin 2 times. On the first flip, it lands on head. What is the probability that coin will land on head on Sally's second flip? Dependent or independent event? Okay, that's all for dependence and independence event. Special thanks and credit to Mathematics Form 4 Textbook KSSM. Okay, see you again. Have a nice day. Bye.